After relation we will see what is meant by function. So function is also a relation, but it is a special type of relation which satisfies some property. So if you consider for non-empty sets a comma b, a function or mapping f from a to b denoted f colon a implies b is a relation from a to b in which every element of A appears exactly once as the first component of an order pair in the relation. So in relation is called as a function in which A is mapping from B, where A and B, these are the two sets, non-empty sets. So we know that many times function just like y is equal to x plus 5, this is one function. So here y is nothing but output, x is nothing but input. So we will take different inputs from set A for x, and we will obtain different values of the y. So in relation means relation which is a function, first element of the order pair will be the element from x from set A, and second element is nothing but the actual output after putting the values of x into the function. So whatever the inputs we taking from the set A is called as nothing but domain set, and whatever the outputs we will get after putting the values of x into the function is nothing but codomain set. So in this case so that is domain f is equal to A. Cardinality of f means domain is equal to cardinality of the A, and codomain is equal to B. So it is tried to represent in the form of graphics. So here this is the set A, so that is a nothing but domain, and function fa is equal to B means we are taking different input from domain set and putting into the function. We will get different values of the B, that is nothing but codomain. It is also called as a range, and it is from set B. So all the values of the domain is always used, but it may be possible some values of the codomain is only used. Means after putting the values of A, we will get some values of the B from the B set. Now we'll see in detail about different conditions for the functions, means when we can call the particular relation is a function. A relation is a set of order pairs that we already know. So this is nothing but one relation. Here different order pairs are there: 2, 3, minus 1, 5, 4, minus 2, 9, 9, and 0, minus 6. So domain is the set of all x values in the relation, that is nothing but 2, minus 1, 4, 9, 0. These are the domain set, and these are the x values, and range is nothing but set of all y values in the relation R. So range set will contain minus 6, minus 2, 3, 5, 9. Now see relation represented by the Venn diagram. So a relation assign x with y's. So here you can see that this is the x set A, that is a domain, and this is nothing but range set, which output means set of all y's. So after putting the values of 1, you are getting 6. For 2, output is 2. For 3, 4. For 4, 8, and for 5, 10. So the relation can, in this case, relation can be written 1, 6, 2, 2, 3, 4, 4, 8, and 5, 10. A function f from set A to set B is a rule of correspondence that assigns to each element x in the set A exactly one element y in the set B. So what is the mean of this? So set A domain set, set B range set or codomain set. The x value can only be assigned to one y. You can see that means for every unique input you should get a sum only one values from the codomain. It shall not be like that for one you are getting the two different values from the codomain set, then it is not a function. So here you can see that every one value is mapping with the one value from the codomain set. So all x are, condition is that all x should be assigned, means for every input there should be some output, and that is nothing but all x are assigned. No x has more than one y assigned. For every input only one y is assigned. So these two conditions are satisfied, means must use all the x. Second, the x value can only be assigned to one y only. Then this is a function, it meets our condition. Now see the next example, another example. So this is also relation. So 1 is related with 4, 4 is related with 4, 2 is related with 4, 5 is related with 4, and 3 is also related with 4. So in this case, first condition, that is all x is assigned, this is true. Secondly, the every x value having one value, only one value from the codomain. So the x value can only be assigned to one y. So these both conditions are satisfied, that is all x are assigned, and secondly no x has more than one y assigned. So this is also the function, it meets our condition. Third example relation, that is 1 is assigned to 2, 2 is assigned to 10, 3 is assigned to 8, 4 is assigned to 6, 5 is assigned to 4. So in this case also, but 2 is assigned to 4. Okay, so in this case if you see 2 is assigned to two values, it is not allowed. Every x is assigned to only one values from the codomain. So it is not a function because 2 is assigned both 4 and 10. So our condition is that every x should be assigned to only one y from the codomain. So it is not a function. Check this relation out to determine if it is a function or not. So in this case you can see relation 1 is related with 6, 4 is assigned to 4, 2 is assigned to 2, 5 is assigned to 10. This is also not a function because one value is not assigned in case of this. This 3 is not assigned to any one value from the y. So this is not a function, it doesn't assign each x with a y. This condition is not satisfied. Next, check this relation out to determine if it is a function or not. 1 is assigned to 6, 3 is assigned to 2, 4 is assigned to 4, 2 is assigned to 2, 5 is assigned to 10. This is a function because every x is assigned, each student gets only one grade, more than so these are the grades and these are the student roll number. Suppose this is fine, each student gets only one grade, more than one can get an A, and I don't have to give any D's, so all y don't need to be used. So means in this case all y is not used. So we seen initially from codomain set some of the values may be used, other are not assigned, that is fine. So this is the function. Now we'll see the properties of the function. So depending on the assignment means assignment of the codomain values to the x, there are different types of function, that is one-to-one function, so onto function, one-to-one function, and 1 to 1, on to, and 1. So we'll see one by one. So properties of function f, function f mapping a from b, a to b, is 1 to 1 or injective function if each element of b appears at most once as the image of an element of a. Therefore, cardinality of a is lesser than equal to cardinality of b. So in this case, 1 to 1 or injective if each element of b appears at most once as the image of an element of a. You can see that a implies b is 1 to 1 if and only if for all a1, a2 belongs to a, fa1 is equal to fa2 is equal to a1 equal to a2. Second, f properties is nothing but onto function. In this case, f function f which is mapping from a to b is onto or surjective. That is called onto or surjective if range of f is equal to b. This is domain and this is codomain. That is, for all b belongs to b, there is at least one a belong to a with fa is equal to b. Therefore, cardinality of a is greater than is equal to cardinality of b. A 1 to 1 or onto or bijective function. So in this case, a mapping from function mapping from a to b. If f is both 1 to 1 and onto, in that case it is called as a onto function. For this, cardinality of a is equal to cardinality of b. So this bijective function is satisfying both properties 1 to 1 and onto. In that case it is called as a bijective function. So we'll see example in